Hi, welcome to Lesson 10, Surface Area of Cylinders. We are looking at the key ideas on page 370. If we look at this, you can see that they have created a net of that cylinder. So when you look at that, you can see that you have two circles, and then you also have a rectangle. So the two circles are the base. You have a top and a bottom, and then you have the lateral surface, which is that rectangle. And we know that the rectangle then would actually be the circumference, like that distance around the circle, and that would be the length then of that rectangle. So when we look at the algebra behind it, we see that surface area of a cylinder is equal to 2 pi r squared plus 2 pi radius times the height. And you can see that it's color-coded there for you, so you can make sense out of it. You have 2 pi r squared, which is in red or pink, and you can see that that then coordinates with the base, the top and the bottom of that cylinder. And then you can see where that rectangular lateral surface is 2 pi r h, or 2 times pi times radius times the height. And so when we do these, when we put this into the formula, the dimensions, we're able to come up with the surface area for the cylinder. Let's look at example 1 so we can look a little bit more. Example 1 is on 370. With example 1, you can see where we are just finding the surface area of the cylinder. And so again, they color-coded it for us, which is helpful. So when we look at that cylinder, we can see that the radius is 4 millimeters, and the height of the cylinder is 3 millimeters. When we utilize that formula, surface area is equal to 2 pi r squared plus 2 pi r h, we substitute in the numbers that we have for the radius and the height. So you can see that they substituted the radius for 4 and then the height for 3. Now, looking at this, they bring it down to 32 pi plus 24 pi. What you can do with that is they are like terms. So 32 pi plus 24 pi equates to 56 pi. Once you utilize one of the approximations for pi, which I would use the 3.14, you end up with an approximation of 175.8, as the surface area squared millimeters for this problem. So we're going to look at the on your own problem on page 370, number 1. I wanted to give you another example of how to do these specifically. So the first thing that you would want to do is indicate that the radius is 6 and the height is 9. Radius is 6 and the height is 9. Then we move over here to our formula, which is surface area is equal to 2 pi r squared plus 2 pi r h. So we can substitute in what we already know. So we have surface area is equal to 2. For right now, we're going to leave this as pi. The radius, as you remember, is 6. So we can put that in, 6 squared plus, as you know, we have 2 pi. The radius again is 6, and the height is 9. All right, so the next thing that we need to do then is to simplify. As we go ahead and simplify, we get 2 times pi times 36 plus 2 times pi times 54. The next thing that we need to do is simplify further, and we end up with S is equal to 72 pi plus 108 pi. And then when we finish, we have surface area of 180 pi. In using 3.14, we get 180 times 3.14, and that's going to give us the overall approximation of 565.2 yards squared. Moving on to example 2 on page 371, you'll see that this is an application problem, and it's asking us how much paper would be used for this label that is on the can of peas. So we don't need to find the surface area of the entire cylinder. We only really need to do the lateral surface area. And so that part of the formula is 2 pi RH. So with this problem, it's a bit more simple, where we're just using this part of the formula. So with this, we can see the radius is 1 and the height is 2. So when you supplement those numbers in, you get 2 pi times 1 times 2, which gives you 4 pi after you've simplified. 4 times 3.14 leaves you with an approximation of 12.56, and this would be square inches. So your final answer is 12.56 square inches of paper is used. Example 3 on page 371 is another type of application problem. So here, we are still using the information from example 2, where we had the pea can, and now we have the tomato can. So it's asking us how much you can expect to earn for recycling the tomato can. Assume that the recycle value is proportional to the surface area. So the first thing that we have to do is find the surface area of each of the cans. So you can see where, for the tomato can, they've done the work for you. You end up with 30 pi as your surface area of the can. For the peas, you look at that, and again, we didn't do that in example 2. We only did the lateral surface. So here we had to do the entire surface area of the can, leading us with that final answer of 6 pi. So if you look at the relationship between 30 pi and 6 pi, you can see that there is a relationship there. Within the very first sentence of the question, it does tell us that we earn 1 penny for recycling the can in example 2, which was the pea can. Here, the textbook asked us to set up a proportion. And so that's what they did. They took 30 pi over x, because we don't know how much we're going to recycle that for, is equal to 6 pi over 1 penny. They cross-multiply, just like we learned earlier this school year, and they are left with 30 pi times 0.01 is equal to x times 6 pi. When we simplify, we end up with 5 cents. So the final answer for this problem is you can expect to earn 5 cents for recycling the tomato can. Hi guys, I hope that that's helpful. Go ahead and work on your assignment, which is page 372 and 373. And I would like you to work on 3 through 11, the odd, number 12, the error analysis question. And then also 13 and 17. Okay, give those a try. And then most of those answers, Bob has the answers for. So make sure that you check yourself. And then I'll see you in class at 11:30. All right.